My name is Navinesh Harungunalan and my metric number is B0921103994. So I'm here today to present about my group assignments abstract. This assignment's purpose was to create and design a spur gear train that would effectively accomplish the objectives and purposes of this task. We must research gear train design and computation for this task. We must also identify the various types of gear train and their purposes, not only spur gear, all the other gears. We use the internet, reference material, and class notes to gather all our information. Along with our group members and also lecturers, we discussed about this as spur gear train. Over a month, extensive studies was carried out. Our investigation determined that the issue with spur gear is that they are extremely slow in speed. After completing this assignment, spur gear's speed has been improved and also increased.
Introduction. A gear is a spinning circular machine. It has teeth that are cut in case of cogwheel or gear wheel. Inserted teeth known as cogs, which mesh with another suitable tooth part to transmit comfort, torque and speed. Similar to the fundamental principle of lever, gear basic operation is based on similar idea. And spur gear, which we call also as straight cut gear, is the simplest gear. They are made up of a disc or cylinder with radially projecting teeth. The tooth face are straight and parallel to the axis of rotation when view side of 19 degrees. The shaft length, which means is 19 degree of the shaft length. Okay, in most cases a tooth cross section is not triangular when viewed along the length to the shaft.
Hi everyone, my name is Bhuvaneswaran, son of Mahabaleswaran. I am from BMME 2/1 and my metric number is B0921100183. I would like to continue the presentation with materials that use for gears. The first material is stainless steel. Stainless steel is carbon steel and categorized as the mild steel or carbon steel. It is very high durability, that's why it's used in gear system or gear train. The second one is aluminum alloy. Typically aluminum are used widely in production of gears because of its high resistivity against the heat and its durability. Okay, the next slide is about the gear type we chosen. As we all know, it is the spur gear, and this is what we managed to fabricate or design. Okay, here there are two gears combined together synchronously, a bigger one and the smaller one. The smaller one we called as driver gear and the bigger one we called as driven gear, which means the smaller gear drives the bigger gear, so it will multiply the torque. Even though both of the gears have different specifications such as different tooth numbers, different diameters and different resistivity. Okay, that's all for the gear. I would like to continue with the design. Okay, this is what we are able to design in CATIA software. Okay, there are three pictures. The first picture is about the gear assembly, and which means that includes the driven gear, driver gear and the parallel shaft to hold that gears. Okay, the second one is the actual gear. As you can see there is a gear with number of tools with a decent number of diameter. The last one is the parallel shaft. It is to hold both gear when it is rotating. I think that's all from me. Thank you so much.
Hello guys, my name is Bang Jiazin. So I brought to you the calculations of our assignment. First, the small gear 1 acts as a driver, has a diameter of 45 mm, and the big gear 2 driven has a 70 mm in diameter. There is 12 number of teeth in the small gear 1 and 15 of teeth in the driven gear. Both of the gear same 30 millimeter of weight. Next, we came to the small gear 1 drive and driven. So we will first convert the diameter of the small gear and big gear to from millimeter to meter. So next, we will calculate the ratio of both gears and the efficiency of both gears. So we use n driven velocity over driver velocity, then we get 1.56 of the gear ratio. So if small gear 1 driver has negative 250 RPM because it is anti-clockwise, so what will be the N2, the rotational speed of the second gear? So we will take the 250 RPM times 1.56. So it will become 390 RPM, positive clockwise. Then we came to the next slide, which we will take input of the torque in the first gear is 18 Newton meters. So we will calculate the power input of the first gear. We will take the calculations, the formula 2 pi nt over 60, which means 2 pi times 250 RPM times 18 Newton meter over 60. So we will get 471.24 watt input power for the first gear. If the power efficiency is 90%, so what is the power output and the torque output? First, we will take the N efficiency formula. P in equals over P out. So the efficiency is 0.9, which is 90%. So we will take 471.24 watt over P out. So the P out is 523.6 watt. So we came to the next slide. So as usual, we use the power formula, which 2 pi nt over 60. So we use the power of the input, that means output, 523.6 watt equals to 2 pi 390 RPM T out divided by 60. So the T out is 12.82. So why the output of the torque is lower than the input of the torque? As we can see in the previous given, is the efficiency of the gear of the mechanism is 0.9 or 9%. So it will suffer a bit of power loss.
For discussion, what is gear train and its usage in automotive industry or any other relevant industry? Number one, gear that working correctly to produce over gear ratio known as gear train. Okay. Number two, set or two or more gear mounted rotating shaft transmission that directly influence the movement of the vehicle. Okay, for number three, and the last one, the driven and the driven gears are the factors that affect the speed ratio.
Hello, my name is Nurul Husna binti Azno. My metric number B092110050, and I will continue our presentation with the conclusion. The conclusion is a spur gear is a cylindrically toothed gear that transmits mechanical motion. Its teeth are parallel to the shaft, and the effectiveness of a building is governed by its design, building, and materials. We develop our understanding of gear during the task, including how to create the gear drive. And lastly, we also know how to calculate the gear parameters such as helix angle, the number of teeth, the center, the distance, and the gear ratio. And moreover, we had all acquired the knowledge necessary to choose the right equipment. That's all for me. Thank you.